So I wanted to make a quick video clarifying and comparing the sum of all forces and the sum of all moments. Let's go ahead and real quick and add force of weight, since this was weight over here, and we'll change this to force of weight as well. But now I want you to make some note about moment 1 versus moment 2. As you can see, moment 1 is clockwise, and moment 2 is counterclockwise. And so in order for this statement to be true, that moment 1 and moment 2 combine to be 0, it means they have to cancel out. It means all of our clockwise moments have to cancel out all of our counterclockwise moments. Therefore, moment 1 equals moment 2. And then we can make this statement even clearer by saying, well, a moment is a force times distance. We know its force here, this moment 1's force. Well, it's going to be multiplied by its distance from the pin. And I can even draw it right here. Here's the pin, and here's distance 1. And this moment is there's this distance from our pin. And then we can do the same thing. We can measure the distance. And let me pick a better color here. But we can measure the distance to moment 2, which I will call distance 2. And the distance is multiplied by the force to give us our moment. So distance 2 multiplied by the force to give us our moment 2. And so we can rewrite this to say the force of weight of Anderson multiplied by the distance, 1. Well, that's moment 1, and that's equal to the force of moment 2, which we called RC. So, okay, RC multiplied by distance 2. And these are the same equations. And then we can do something similar with our forces. The sum of all forces have to cancel out as well to equal 0. And so we can say our two reactionary forces, which are going upward, cancel out our downward force. So we can rewrite this to say RA plus RC is equal to the force of weight going down, because they have to cancel out. And you might say, well, Mr. Anderson, how come there's 3 forces but only 2 moments in the same system? You have force of weight and RC, but why doesn't RA? Why doesn't RA? And let me put RA in its correct color, in its light green color, as we've labeled it already. But why does RA have no moment? And why do our other 2 forces have a moment? And the answer is, well, the moment is the distance from the pin. It doesn't matter how big RA is, the distance is always 0. So RA could be 11 billion, and 11 billion times 0 is, well, a moment of 0. Therefore, there is no moment at the pin. And hopefully this clarified some concepts about sum of all moments and sum of all forces.